we went through a number of topics around CXL. We built up the story individually, piecemeal. And towards the end of the talk this morning, I suggested that having done all those little pieces, we can create large systems based on fabrics, and we could disaggregate memory. And as we disaggregate memory and computing, then the flip side of the same coin is composing a system based on disaggregated components. So it's great that we have the panel here, experts in doing that. And that would be great if you first introduce yourself and then we go through the topics.
Yeah, great. My name is Ben Bowles. I'm the Director of Product Management at Liqid. We are a composable infrastructure software vendor. So when we've been talking about composable memory, a lot of what we're focused on is, how to compose the memory, storage, GPUs over fabrics to hosts. And so looking forward to talking more about that on this panel. Thanks.
Okay.
Test one. Test two.
My name is Jerry Fan. I'm a CEO and co-founder for a startup called Xconn. So the Xconn was started about 2 years ago, and we are building the CXL switch silicon. And I'm very excited and also pleased to say that recently we got our first silicon back in our lab, and is alive, is up running. And of course, we still have a lot of validation need to be done. So our chip is the most powerful in terms of the switch capacity, and latency is extremely low, and actually is better than what the spec need to be. And so we are very excited to have that chip in our lab, and I think our chip is going to be one of the key components for the composable data infrastructure.
All right.
Hi, my name is George Apostol, and I am co-founder and CEO of elastics.cloud. At Elastics, we're solving the connectivity problem in the sense of being able to connect elements with CXL. But from our early days and background at PLX technology and developing PCI Express switches, we learned that the problem is more than just connectivity. And so what we're developing is a smart SoC, right, that can be used to compose these systems smartly, intelligently, and with the flexibility to be able to meet the demands of workloads.
And my name is Christopher Cox. I'm a VP of Technology at Montage. And we also have silicon. Actually, we have the first industry silicon for a CXL DRAM controller. So we support DDR4, DDR5. And we actually have it running in the MemVerge booth, so you can come and see it. It's actually also being shown in several other booths as well. So it's out there. I'm really excited about this, actually. We're a hardware manufacturer. So we're kind of the beginning of the puzzle. But we see the value of having that software interface and the fabric manager, because long-term we really need that pooled memory.
Very good. Thank you very much for coming here. We have tough problems ahead of us, and I'm glad that we have experts in different areas. Memory controller, switches, software, and control plane and bridging components. It's very good to have all of you guys here. So earlier in the talk, there was references in amount of memory that's being used in large data centers, specifically a comment about a lot of memory that's not being used. So we're at Flash Memory Summit. I just want to make sure that we all know we're not trying to reduce the amount of memory people use. We would like to actually use them very efficiently. So there is a law, Parkinson's law, you perhaps are familiar with. He said that work will occupy the entire time that you allocate to it. So the corollary to that for our business might be that computing will grow to occupy the entire memory footprint that you allocate to it. So let's just make sure that footprint of memory is in fact available and ready for computation to take advantage of. So basically getting rid of stranded memory and increase the utilization of memory. So with that, people have proposed that disaggregating memory is a good thing, disaggregating computing is a good thing, but that will create challenges along the way as well. So today, we're going to talk about the motivations for disaggregated computing, challenges that are there that we as a community need to resolve, and then the solutions and the tools that the good team over here is working on to eventually produce good results. So we can start going around the table, and each one of you guys, perhaps you can tackle specific part of this multifaceted challenge. Please.
Yeah, I think that's a really exciting part of what we're about to accomplish with CXL and disaggregated memory. At Liqid, we have a lot of experience with disaggregating things like storage and GPUs, and then utilizing software to drive up the utilization and the efficiency of those resources. And so we see a similar possibility with being able to disaggregate memory over a CXL fabric and then utilize our software to be able to compose that memory to hosts that need it at a particular time. And then same software can uncompose the memory out of those hosts when they're done using it. So that's a pretty simple, straightforward way that we see driving up new levels of efficiency around composable memory.
Very good.
So,
Your mic doesn't like you. You want my mic? Sure. Thanks. I don't know if I need a mic.
actually, about 2 years ago when we started the Xconn, actually one of the reasons is we choose CXL because we run off the idea what we need to build. So at that time, CXL actually is I should say like lukewarm, and it looks pretty promising, and so we choose that direction on our vision. And over the 2 years, and as you guys can see now, right now the CXL become the sizzling hot, and it's going to get hotter and down the road. Over the 2 years, during the time when we built the CXL switches, we are pretty much built from scratch, and basically we're working with the cloud providers, we're working with the OEM system vendors, and also memory, CXL memory controllers. So we definitely see the trend and the entire ecosystems, and to get galvanized under the major CPU vendors, and they are moving much faster and more supportive to put the CXL into their processors. So by saying that is, I think this is going to be a phenomenon, and somebody said it's evolution. I think it's really going to revolutionize how this computing get done in this industry, and especially for the composable, and that will be saving the billions of dollars for the data center providers. Yeah.
So one of the things that we looked at when we started elastics.cloud was really what problem are we trying to solve? And from the history of PCI Express, we've gone through the pain of trying to be able to connect these devices as efficiently as possible. And the protocol just really didn't allow us to do a lot of things. right? We tried with SRIOV, and one could say that that's been moderately successful. MRIOV, total disaster, right? It was really, really difficult to make that work. And then we came along with the Capella and the Capella 2 functionality that we built into our switch, which enabled companies like Liqid and GigIO and others to be able to write a software layer to be able to create that management, right? We believe now with CXL and the additional functionality and capabilities of CXL, it will give us the capability to do things that we have not been able to do before because of the PCI Express paradigm, right? And by allowing the sharing of these devices, that's what's going to enable the disaggregation. But as you can tell by the discussions that were up here earlier, there is a lot more that's needed in order to make these systems run efficiently at the system level. There's a lot of software that has to be created, right, in order to be able to make it use. It's not just we're going to pull out PCI Express, throw in CXL, and the world is going to be great, right? There's a lot of work that needs to be done. There's the management of those interfaces, the management of the resources associated with the things that they're connected to, the composability, right? You got to be very careful because composability is being thrown around like a really easy word. But you got to ask yourself, where does the control of that composability lie? And based upon where that control is, what does that do to your system performance? So these are the problems that elastics.cloud we're looking at. And how do we create these designs so that we can be not just connected to all of these devices, but to be able to manage them intelligently and efficiently.
So I'm going to look at, this is one word, okay. I'm going to look at it a little bit differently. I spent 20 plus years as a memory architect, so I'm kind of looking at it from the hardware design. And I've been working on trying to figure out how to do dynamic allocation, deallocation of memory, and then how to do disaggregating the memory controllers for many years at my previous company, which Siamak knows. But until we had CXL, that was really difficult to do. Now at my company, we're just doing the memory controller, which we're partnering up with all kinds of different teams, including SK Hynix, Samsung, Micron, to make devices, modules, backplanes. But what we realized, as good as hardware as we can make, we really need a good switch. And then we also need a good fabric manager too. So the software stack is critical to be able to sell the hardware. I mean, I don't care what kind of DRAM is behind it. If you can't actually get that information to the application, it doesn't really matter. Stranded memory, that should be a call to action because how do you get your TCO down if you don't get rid of stranded memory? Can I do it with my device? No. It's actually a team effort that we really need to have. And I've heard that called over and over, and people say, well, it's a buzzword, composable memory. But reality, that's what we really need to get to the next generation. As a memory controller architect in my old company, we can only add so many channels in the platform. We've got to start figuring out how to move that memory farther away like the storage guys have done for years. And this is now a way we can do it. I mean, we could have a switch with a fabric manager that has an optical interface on the backside that goes to the rack. And then we can just spread it out. Could we do that 10 years ago? No. Did we want to? Yes. But now we're at that inflection point, I think, that we're coming to. It might be a couple years out still, and maybe my hardware is maybe a POC for the software guys for the next 2 years, but the next 2 years are going to be pretty exciting.
Okay, very good. Thank you. So this was a good overview of what the capabilities are. We heard a lot of people talk about motivations for CXL and capabilities CXL brings to us today. But sticking with the three themes of what are the motivations, what are the challenges, and what the solutions are. So let's go to the next stage of identifying the challenges. For example, people say, hey, give me whatever you want to give me, but don't ask me to change my software. That is perhaps a challenge that we can work through. Give me the disaggregation, but don't cause new fault modes. Or if you do create fault modes, you have to fix that problem as well. So if you add complexity, that might come with extra power. It might come with extra space and challenges that are in that area. So would you tackle those areas as well? And at the end, we will go over the solutions that you guys have thought through and the solutions that you guys are planning to do to tackle these challenges.
Boy, we could spend 30 minutes on that, or an hour.
I'm not going anywhere tonight, so be brief as much as you can.
Well, I'll go first because one of the things that we see from a composable infrastructure and the software layer that's required, and I think this will apply for composable memory as it currently applies for some of what we see with customers that are trying to compose other resources like storage or networking or GPUs. A lot of, and I'll echo my colleague at the end, a lot of the challenge that we see is the requests for those resources come in from applications or workloads. And they really don't care about, well, what's happening under the hood to make that happen. So I think we'll have a similar challenge with composable memory. And whether it's a fabric manager API or we're talking to individual device vendor APIs, that kind of thing, intercepting those requests through the end user tools, I think is going to be a major challenge.
Okay, so
And
some
we've seen that already.
standardization will help on
Correct.
APIs or solutions. Very good.
I think so, yes.
Yeah, finding that right balance of how much standardization you need versus too much that stifles innovation, that's the key part, right? You don't want so much standardization that it stifles innovation, but at the same time, you need a little bit to kind of kick it, get it started and get it going.
Okay,
And I think that's one of the same problems we have as well.
very good.
So based on our experience, and because we're working with major CPU vendors, we are working with the pretty much all the memory vendors. And one of the challenges we can see that is you have the CXL 1.1, 2.0, 3.0, so which is coming at different time of stage. And for the entire ecosystem, it's really important is for the vendors in the different segment need to be lined up. And for this lineup is one of the challenge because the CXL is basically evolution. So that involves all the moving parts to be coherently and moving together. So if one of the chain is lag behind, so that will cause especially for example, for the end user like Amazon, Google, Alibaba, and these cloud providers, they will get pondering, and if they should adopt these type of technologies. So I echo what Siamak said this morning, and I think it's very important for different vendors to come up with something common and can be deployed at the very near future so that every vendors can be lined up. We can build the system and start analyze and to find the best utilization in terms of the memory pooling and to improve the memory utilization and also to see the great benefit of the CXL.
So one of the big problems that we're seeing with our customers and the things that we're tackling is not just the disaggregation of the components, but the heterogeneous nature of the compute elements that now are needed in order to meet the performance required of these systems. Right now we've got CPUs and GPUs and DPUs and TPUs and XPUs, all these specialized processors designed to do what they do best, right? And now we've got to connect all of these things together to be able to talk to these pooled resources, right? And the question keeps coming back over and over again is who manages it all, right? If you create a central location to manage all of these devices, now you've just created another straw, right, through which everything has to get, bandwidth has to go through, and you limit yourself from, not just regular bandwidth, transaction bandwidth, right? And if you look at a server today in a data center, not only is a dual socket server, one of those sockets is used just to move data around. And it's not just moving data, it's also transforming data. Because an Ethernet packet doesn't look like an NVMe packet, doesn't look like a GPU packet, doesn't look like with all these data deep types and transforms, right? So, we've got to create system solutions, whereby we're being really efficient on how we're accessing that data and utilizing that data, and to have intelligence distributed throughout the system in order to be able to manage that accordingly, right? These are the things that we believe is going to not just leverage the connectivity, but is going to create orders of magnitude greater performance.
Challenges. It's kind of like peeling an onion, right? At first level, you say, oh, okay, how much bandwidth do you need? What's the latency targets? Then you start looking at the other set of features. Like for right now that we have silicon, we see that our bandwidth is 95% of a local memory access, so that's pretty good. Latency is like a NUMA hop. Okay, what's next? Well, now I got to peel it back a level. I start realizing, do I have the right RAS features? Do I have the right connectivity features? Do I have the right CXL features? Have my CXL 1.1, 2.0, 3.0, 3.1? And then do I have a switch that's ready to handle that? Do I have a fabric manager that's ready to handle that? So I think the biggest challenges are understanding the software that we really need. Because like I was saying earlier, I can make the hardware, but if I don't have that killer app and that software to really drive it, I'm not going to go anywhere. So I think that's the biggest challenge, is the software ecosystem going to be ready to step up. And as you can see, we have switch people, we have software fabric managers stepping up. That's the great thing that we didn't have in the past. And yes, it's going to be a challenge over the next couple of years, but there are people rising to that challenge.
Very good. So that's a segue for me to actually invite the audience. If you guys have questions, please come and ask. While you're doing that, I'm going to ask another question from the panelists. So here we are with a lot of smart people in the room. How can they help you achieve what you guys want to get? It's basically a call to action to people. What is it that they can help you with?
Well, I'm a firm believer, like a communal thought, right? That the more brain power we have on it, the better we are, because an individual is only an individual, and you can only think so well. I really need to get everyone to start thinking about the problem and start coming up with ideas, because you get 5 people in a room, and all 5 of those people are going to individually contribute more to the sum than one person could. So I'm sure there's somebody in this crowd that has an idea that says, hey, I need my composable memory to do this. This is the challenge that I'm facing. How are you guys trying to address that? Or how are you gals trying to address it? We really need that kind of feedback, because sometimes we're trying to design it inside of a box, and it's so new and fluid that it moves around so much that we really need to get a lot of feedback, not only from like CSPs like yourself, but also the end users.
Yeah, I mean, I think one of the lessons that we learned at PLX is there's the way the spec is written, and there's how people design it, right? And so this is why I think shows like this are very important for us as an ecosystem and a community, so that we can engage with the various companies that are looking at developing systems around our technology and ensure that we've got that compatibility. And that compatibility is not just connected to the networks, the hardware, it's also on the software side. I mean, I have had every CXL IP vendor's IP in my lab, and none of them work the same way, right? And it's a big issue when you go and you try to bring up real hardware, right? So we have real hardware running as well in FPGAs, where we're demonstrating the ability to pull memory over CXL, and also through other interfaces, which we will be discussing later. But and in order to get that to work with the various processors, the various memories, all the technology that's out there, has been a real challenge for us, because like I said, there's the spec, and then there's how the other vendors do it. And so I think, for us, I think it's going to be real important that the ecosystem, come together like we did with PCIe and PlugFest, right, and start to open up our ability to ensure that we have this compatibility.
Yeah, I would like to echo what George said, that that should be a collective effort for the ecosystem. So, for example, we are the silicon switch web vendor. So we can knock ourselves dead to make latency extremely small. But if the CXL memory vendors has like 200 nanosecond, 300 nanosecond latency, then the game over. And so if the CPU vendor like keep delaying for this kind of deployment, then it's also going to be the trouble for the CXL deployment. So that's, and also in terms of software perspective, and we definitely don't want the application get changed. So we need some guy, like a Liqid and Manverge and VMware to come up with those software, basically the shielding for the application to change. So if you want the people who change the application, they will say no. So definitely that's a collective effort. Without the success for the chain of this ecosystem, and to get CXL deployment, that's not going to become possible.
Yeah, I think you're right. Well, are we going in order? Does it matter?
Well, I'll go and then summarize. I mean, I think from what I see, there's a lot of that ecosystem coming together to be able to create an end-to-end solution. And I think this panel represents a lot of the pieces that need to come together. So
Very good.
I'm excited about that.
So it's, again, I'm sure I've not asked all the good questions that you guys have, but we have a question coming, right? Okay, please.
So in terms of composable, so I come from the SSD world where composable storage has been a great boon. The problem for us in the SSD world is when all these drives are behind a switch, and then that switch only has a NIC, that's a by 16 connected NIC, the fastest throughput you're going to get through an array of drives is
You're
going to
bottlenecked
be...
by the NIC, right?
Yeah, so now we get to CXL, and we have, let's say, each of these CXL memory modules is 1 by 8. What's the bandwidth? How are you actually going to deliver memory-based bandwidth and memory-based latency through a composable infrastructure when you have maybe like 1 or 2 NICs in the system? Like, what are we going to need to do at the server level? What are we going to need to do at the hardware system application layer that, multiple CXL NICs, or how do we deliver,
But your optical NICs, you're going to have to do that to keep the bandwidth up. I mean, if you just choke it down to the bandwidth, then it's going to be not very valuable, right? And that's going to be a problem. I mean, with storage, I think your bandwidth is an order different than on DRAM size. So you're going to have to put some high bandwidth interfaces to the CPU arrays. And I say CPU arrays, I mean, that's what you're kind of doing, is disaggregating the CPUs from all the memory. And it goes through a switch, but yes, the switch will make sure it's being, and the fabric manager will be making sure that it's used effectively. But if you can't get that data back to the CPUs, then it's a problem. But I would assume that all the CSPs and everyone else here is looking at, I got to make sure that back end is not choked out too.
Right, it's the back end that I'm really getting at, right?
Yeah, it's got to be.
1 by 16, or there are 5 of them, and then you run into how many lanes that you get out of a CPU, right? If we're at 80 lanes from a certain vendor, or 100 and whatever.
I mean, most of these guys are at 128 right now, and by the time this deploys, 256 probably, and they're probably going to be PCIe CXL hit switch hitters. And you could see an EDSFF front end that has a bunch of by 4s, and they put storage NVMe drives in there, or they can put memory expansion. And if you've got a good fabric manager and a switch that can just handle them, it's like a switch hitter. It can be any kind of device. It can be storage and or memory, and it just has to have a good pipeline back to all the CPUs.
So on the CXL specification, at least, it offers interleaving across all the CXL links of any device. So the CPU can have as much bandwidth that it needs to across all of its CXL root ports. So that's where it starts from. Now on the system side, of course, we have to have enough system devices to feed that much bandwidth. That is part of the platform design. I'm here. Yes, Steve, please. Right. Steve is reminding me to mention that with the PCIe specification, today we've had to follow a tree structure. If a device wanted to expand, it just had to follow a tree. With CXL, as we discussed this morning, you could have multiple trees, and these trees can fabric connect to each other. So the data can actually move from branch to branch across the fabric ports and fabric links. So that creates a very good device-to-device, peer-to-peer interconnect outside of a choke point that you might have in the past from the CPU being the choke point.
Right, that peer-to-peer functionality is huge.
Right.
It's a big value, and
Right.
the many-to-many relationship too.
Again, capabilities are there, but I'd like to keep us on the theme of new challenges are there too. We need to debug all of these things, and we need all of your help to go through the compliance, read the specifications, ask questions, provide feedback, come up with the use cases as you guys mentioned, so that we as eventually community can produce better results. I'm sure we're running out of time, but Pankaj?
Okay, so I'll make this quick.
Okay.
I think when hardware people think about software, it's always funny. We don't want it to change. We want to remain it same forever. And we forget that after fiber channel, we got in-memory computing because we got so many IOPS. We got better storage. So our belief is we are a new company, not mentioned as a CXL software company. We'll be giving a talk tomorrow. Elephant's Memory. We are actually enabling new software that enables near memory compute. So we are thinking that load store only access to far memory is not going to be enough. So some function will gravitate to data. So I just comment or an objection to everything you were saying, which is yes, better software will enable better use cases for
Very
sales.
good. So I thank the audience, I thank the panelists, and I thank members to give us this audience. But you see what just happened. The team over here asked for help, and from the community of good people, there was a solution provided. So thank you all.